base b of 1. Okay, so that means it's equal to 0. Right? Why this is true? Because we know that means 1 is equal to b to the 0. Yes, that is correct. Log b to the base b of to solve some equations. Log 8 of 64 equals x. Okay, so there are several ways, two ways to solve this equation. The first one is you can use the equivalent form. So that means 64 equals a to the x, right? So which power of 8 equals 64? So it's very obvious, you can guess this would be x equals 2. Right? So this is the one way. Another way is we want to use the properties we have. So the log to the base 8, 64 equals log to the base 8 of a squared. So we can use this property. You can bring down this power 2 in front of the log, so 2 times log 8 of 8. Log 8 of 8, then we can use this property 2. Log b of b equals 1. So log 8 of 8 equals 1. So this is 2 times 1, which is equal to 2. So x is equal to another one, log 9 of negative 9 equals x. What is x? So I would say there is no solution. Because we have no other ways to get 9 to the some power x equals negative 9. There is no solution, right? Another way is this one, this position. You remember, log b of x. This one requires this x should be greater than 0, but here negative 9 is less than 0. So this one is undefined, so this x is undefined. In other words, this x has no solution. Okay? So now let's look at, so here some special logarithmic function. Log function. One is called the natural log. Natural log. Natural logarithmic function. Logarithm. That means which is denoted by ln x. ln of x. So that means the base of this logarithmic function is e. E, we know it's a number about 2.7, right? For this special one, we use the ln x. So most time we will use this one to do the further calculation. Another one is the common logarithm. We use the log log of x. That means the log to the base 10 of x. If the base is 10, we just write it as log of x. Okay, but why we want to introduce these two logarithmic functions? The reason is if you look at your general calculator, you will see you can calculate the natural log ln of x and common logarithmic function, common logarithm, okay, log. You can find it in your calculator. There is some button to calculate this kind of logarithmic function directly, okay, if you plug in x some values. So now you should be familiar, you should be able to know how to evaluate the expressions about the common logarithm and the natural logarithm. Okay. So now let's look at other examples. ln e equals x. What is x here? So we know that there's still two ways. The one way is ln is the log to the base e, right? So e equals e to the x. Right, this is actually, I can rewrite this one. So that means it's the log to the base e of e equals x. So that means e equals e to the x, so x must be 0. X must be 1, right? There's no other choice. The other way is we use the property log to the base e of e, which is equal to, if these two numbers are the same, it's equal to 1, right? That is the property 2. So x equals 1. Okay? So the next one, we want to simplify. We want to rewrite the logarithmic function using the properties we have already learned. Right. For example, for this one, it's equal to, here is this 9 times x to the 5th, so you can separate. So it's separate to log to the base 3 of 9 plus log to the base 3 of x to the 5th, right? So here is plus, here is multiplication, right? So we know that 9 equals 3 squared, so this would be 3 squares. And plus, you can bring down this 5 in front of log, so 5 times log 3x. So this equals 2 plus 5 times log to the base 3 of x. Now let's look at another one. Is we want to condense the following logarithmic functions into a single logarithm. So this is the natural log of 3x plus natural log of 2y equals what? You can put together because they have the same base. Natural log, the base is e. So you can put together, then this would be the 3x times 2y, right? So it's equal to natural log of what? 6xy. If you have 2 log of 2x minus log of 3y. So we want to condense this expression. So the first thing is we want to put this 2 inside the log. But we know if the number in front of this log, this number, if you put inside, it would be the power of this part, right? So it would be the log of 2x whole thing squared minus log 3y. Then these things, they have the same base. You can combine these two logarithms. So it would be 4x squared, this is 2x squared equals 4x squared divided by 3y. Yes, that's it. So now let's look at the following one. 3 plus 10 log to the base 2 of x minus 7 times log to the base 2 y minus 5 log to the base 2 z. Okay, so now let's look at if we want to combine these three terms, four terms. The first thing is we should keep this one as a log, so we should put 10 inside, so it becomes log 2 of 10x to the 10th power. Right, this is the property. Minus log 2 to the 2 of the y to the 7th power minus log 2 z to the 5th power. Okay, so you can combine these three. So let's combine these two first. So this would be log 2x to the 10 divided by y to the 7 minus log to the base 2 z to the 5th. So that is 3 plus log to the base 2 of this one divided by this one. So you will have x to the 10 divided by y to the 5th times z to the 5th, y to the 7th. Okay, so now we want to combine these two. Okay, but this is a constant, this is a logarithm. How to combine it? So the first thing is we should have the same base. So we need to write 3 as 3 times 1. 1 is equal to log 2 of 2, right? Okay, so we can put this 3 inside. So this would be the log 2 to the 3rd, which is 8, right? Plus. So this is 8, you plus together, so then you can multiply the inside. So this is 8 times x to the 10th. So this is 8, right? So this would be awesome. It looks very complicated for this problem, but it will help you a lot to understand the properties of the logarithmic functions. So now we want to look at how to solve the logarithmic equations. Okay, how to solve simple exponential equations and the logarithmic equation.